All right, cool. All right, hello everybody. My name is Nick Mediotti and I'm with Brendan McIntyre and Kate Alonso, and this is our presentation on our two-way memory test. Oops. So the problem that we wanted to address was similar to the one that we had done in our one-factor test, but essentially with employees increasingly listening to music during work, especially during the pandemic with everything being work from home. We wanted to see if the type of music, like the genre of music, actually affects working memory. And then for our second factor, we wanted to look at how much the time of exposure to certain information impacts how well you can memorize it as well. So we included that factor too.
All right, now looking at our hypothesis, so we said our null hypothesis is that all the means are equal to each other. And this is, so we have two independent variables, each with two levels. And then our alternative hypothesis is that at least one of the means is not equal to the others. So getting into it more, mean one is that the mean accuracy for short length and jazz music, and mean two is the mean accuracy for short length and metal music, and then long length jazz music and long length metal music. So the two independent variables are the duration of exposure, which we'll get into more, and then the music type.
So just looking at our lit review a little bit, I just wanted to bring up two big points about both of our factors. There already are studies out there that shows that music actually affects working memory negatively, but nothing is really concrete on whether the genre of music matters. So we wanted to look into that a little bit more. And generally recognition and recall improve upon time of exposure and repetition. So, the more time and the more often you see something, the better you are served to remember it. So we just wanted to confirm that as well.
And looking at our design of experiment, so like I said before, we have two independent variables, the music type and the time of exposure. And this is being exposed to the sequence of characters. And the dependent variable is the accuracy of working memory. And the accuracy is scored by the amount of correct characters in the correct place in the sequence divided by the total characters in the sequence. So our subjects not only have to have the correct character when reporting back the sequence, but they also have to have the character in the correct place in the sequence.
So getting into how we actually did our testing a little bit more. So our test subjects were required to set their headphone volume to about half of the maximum. So just to try to standardize that as best we could. And then we either played jazz or metal music, depending on the group. And then the first sequence we showed was 8 characters. And so that factor was also either shown for 10 or 20 seconds, depending on the group, with a 15-second buffer period where subjects had to use that or memorize the sequence, wait that 15 seconds, and then after that, fill out a Google form from what they memorized from the sequence. And then they repeated that again for the 10-character sequence. So it was a pretty comprehensive test there. And yeah.
So these are the results of our experiment. This is before running the ANOVA or anything. So these are just the averages you can see on the table on the left. We have the 8-character sequence and the 10-character sequence. And these are for all 4 levels. And you can see the means for these percentages. And then on the right, there's a little graph that shows for each level either sequence. And we're kind of looking not between the difference between like the blue and red bar, but we're looking at the differences between all these blue bars, which is the 8-character sequence, and then all the red bars, which is the 10-character. And we're going to be running 2 different ANOVAs for these sequence lengths.
So looking at the results of our ANOVA, we got high p-values for the interaction for both of these. So this is the 8-character sequence on the left, and then the right is the 10-character sequence. So the high interaction p-values of 0.373 and 0.843 mean that we can use the additive model, which allows us to look at each of the individual p-values as well. And then so when we look at those, we see that for both ANOVAs, they're well above 0.05. So we actually could not draw any concrete conclusions from the data that we got. So yeah, that was not exactly what we were looking for, but it was what we got.
Yeah, like Nick said, in conclusion, we failed to reject the null hypothesis because we didn't have conclusive evidence that the true mean accuracy for any of these groups were actually different. You want to go to the next slide, Keeb? And then some industry applications we had, like in a restaurant, like many restaurants have music playing in the background and waiters are trying to memorize customer orders. And then this can kind of be applied to any business where they have music playing in the background, like any receptionist type job. So those were the industry applications that we kind of connected to our study. And if you have any questions, we know this is a recording, so feel free to ask us in lab. And thank you for listening.